Hey folks, it's Perry again, and I'm in here in the garage doing a little science experiment. Now about 4 or so years ago, I did a video on replacing these battery cable leads on this charger. Now, at the time I didn't really think about it, but when I reviewed the footage, I noticed that I had clipped these leads off before I started doing the repair, and that has confused a few people. And I've gotten a few comments asking, well, how do you know which one is the red and which one's the black? Well, the simple answer was, on my charger, the red lead had a red stripe on the wire, so that was really simple. But I realized that not everybody has a charger where the red and the black are so obvious. And I wanted to do a little quick science experiment to show you how you can figure out which one is the black and which one is the red. Okay, so what you're going to need for this experiment is some tap water with normal table salt dissolved in it. Now I've got a glass dish here, but you'll need a glass or a plastic dish for this. The amount in here is 3 cups. That seemed reasonable to me, and I dissolved probably about a tablespoon of table salt into it. Normally it's going to be a little less cloudy than this because I've already used this solution before. But you're going to get a somewhat cloudy solution of salt water. That'll be your electrolyte for this test. Then you need 2 pieces of aluminum foil. This is just normal household foil. You take that and then you fold it over the side of the dish so that part of it is submerged in the water. Like so. Make sure that they are not touching within the water. That would not be good. Now you've got a glass dish with 2 electrodes formed by aluminum foil in an electrolyte solution. So what's going to happen is when we attach the battery charger to this, electricity is going to flow in what's called electron flow order. Now, when you were a kid, you might have been taught that power goes from plus to minus. Well, yes, that is what you would consider conventional flow, but in this case, we are going to be using electron flow, and when you put a battery charger or you put a charge across water, you get what's called electrolysis. It splits the water into hydrogen and oxygen. Because there's 2 hydrogens and 1 oxygen, H2O, you're going to get a much more vigorous response from the hydrogen side than you will with the oxygen side. Now, the hydrogen side will be the negative, or the black lead of the charger, and the oxygen side is going to be the red lead of the charger. So when we connect the leads up, even if we don't know what polarity they are, we're going to see a much more vigorous response from the side that's black because there's twice as many hydrogen atoms in water than there is oxygen. So next, you need your charger set on the lowest amperage setting. This is a 21050 amp charger. So I'm going to set it at 2 amps, and I'm going to make sure that my 2 leads, which if you don't know what polarity you've got and you're missing your leads on the end, just make sure the ends of your wires are not touching or in danger of touching. Now you're going to plug the charger in. I've got an indicator light saying the charger is on. I'm going to connect one of my leads to one of the electrodes, and I'm going to connect my other lead to the other electrode. And right away, I see a much more vigorous response from the side with the ground than the side with the positive. You can see there's a whole lot more bubbles and foaming and fizzing on this side than on this side. That's because this is the hydrogen and this is the oxygen. Now, you might say, oh, that's dangerous. Well, you can see there's no flames being generated. It's just a bunch of little bubbles. It would have to build up a lot to be able to be combustible. But just be cautious. You know, this is generating hydrogen and oxygen, and those are combustible. Well, hydrogen is combustible, oxygen is an oxidizer. But you can see there's a lot less activity on this side over here than on this side. So now consequently, this is one of the ways that you can remove rust if you're using washing soda. So you basically dissolve washing soda in water, and then you put the part you want to de-rust on the negative electrode, and the part that you are using as a sacrificial electrode to draw the rust, you connect that to positive and you stick it in the solution, and the electron flow and hydrogen will push all that rust off of the part and it'll clean it up. Well, that pretty much concludes the video. You've seen here I've got just a simple charger with a couple pieces of tin foil and some electrolyte solution made of table salt and water, and the more vigorous side of the reaction is the negative and the less vigorous is the positive. And that is how you can use science to determine the polarity of your charger.